Welcome to today's session. Today we will see problems on trains, short tricks and concepts of how to solve problems regarding trains. Problems on trains are nothing but applications of time, speed and distance. The same time, speed and distance what we learnt earlier, the same time, speed and distance concept or the same methods we will use in solving problems of trains. Problems of trains is nothing but it is the application of time, speed and distance chapter. So let us see some basic things and then we'll begin with the problems. So three important things what we have to remember when solving problems on trains is the distance covered by train when it crosses different objects. Okay, when it crosses different kinds of objects. So in that, first one is point object. Okay, distance covered by train when it crosses point objects. For example, point objects are man or pole or a tree, etc. Okay, point objects means it can be a man or a pole or a tree. So when the train crosses any of these objects, how to calculate the distance covered by the train? So the distance covered by the train when it crosses point objects is given by the length of the train plus the length of the man or pole or tree. Okay, but we know that when compared to the length of the train, length of a man or a pole or a tree is negligible. It is just negligible. Therefore, we can consider only the length of the train. So, whatever is the length of that train, that itself is the distance covered. Okay, so the distance covered by the train when it crosses any point object is given by its own length. Okay, it's the train's own length. Secondly, when the train crosses a platform or a tunnel or a bridge. Okay, when the train crosses any platform or tunnel or bridge, that time the distance covered by the train is given by the length of the train plus the length of the platform or tunnel or bridge. Here in this case we cannot neglect the length of platform or tunnel or bridge. We have to consider it. So the distance covered by the train when it crosses platform or tunnel or bridge is given by distance is equal to length of train plus length of either platform or tunnel or bridge. Then the third thing, when the train crosses another train. Okay, when the train crosses one more train, another train. Okay, that time the distance is given by length of the train plus the length of another train, of that another train. Okay, length of that particular train which it is crossing and the length of that particular train. Okay, so the distance covered is given by the length of the train and the length of another train. So one more thing we need to remember is relative speed. Okay, we need to know what is relative speed. Relative speed is the relation between the two speeds, okay, when two bodies are moving, they are moving with different speeds, isn't it? So the relation between those speeds is nothing but relative speed. When two bodies are moving in opposite direction, okay, when two bodies are moving in opposite direction, okay, two bodies can be anything, two trains, okay, or a train and a car, like this, okay. When two bodies are moving in opposite direction, that is, one is moving in this direction, another is moving in this direction, so the speed of first train and the speed of the second body, okay, we have to consider the speed of both the bodies. So that time the speeds get added, s1 plus s2, okay. So the relative speed, this is nothing but relative speed. The relative speed when two bodies are moving in opposite direction, the speeds get added. Then the second condition is when two bodies are moving in same direction, okay. When the two bodies are moving in same direction, that is, both are moving in one same direction. So if this is s1, this is s2, okay. So that time relative speed is given by s1 minus s2. That time both the speeds get subtracted. When the two bodies are moving in opposite direction, the speeds get added, and when they are moving in the same direction, the speeds get subtracted, okay. So these are the important things what we need to remember or we need to know before solving problems on trains. One more thing is converting, okay. Sometimes the units given are not same, okay. It can be kilometer per hour or it can be meter per second, okay. But if the question, the problem or the speed is given in kilometer per hour, but in the answer or in the options the answer is in meter per second. So how to convert kilometer per hour into meter per second? So the first thing, to convert kilometer per hour into meter per second. So how to convert it? Just multiply the given number by 5 by 18, okay. So how you got that 5 by 18? See here, kilometer per hour means 1 kilometer per 1 hour, okay. So 1 kilometer is nothing but 1000 meter, and 1 hour means how much? It is how many seconds? It is 3600 seconds, okay. So 0 0 0 0 cancels, 2 5s are and 2 18s are. So what we get? It is 5 by 18 meter per second, isn't it? So same way, when we are converting kilometer per hour into meter per second, when we want to convert, we have to just multiply the given or the number, okay. The number is multiplied with 5 by 18, then it gets converted to meter per second. Now same thing, if we want to convert meter per second to kilometer per hour, okay. So then what we have to do? We have to just multiply the given number into reciprocal of the earlier, that is 18 by 5, okay. That time what will happen? Meter per second is converted into kilometer per hour, just the opposite of this, okay. So this also we need to remember before starting the problems. So let us begin with the first problem. How many seconds will a train 100 meter long running at the rate of 36 kilometer per hour take to pass a stationary pole? Okay, so they are asking how many seconds will a train length is given, it is 100 meter long, and the speed of the train is given, how much? 36 kilometer per hour. Okay, so it is passing a stationary pole. It is passing a stationary pole. So how many seconds it will take to pass that stationary pole? So time is how much it is asked. So we know that time is nothing but distance upon speed. So we know the speed. So what is distance? Distance when the train passes a stationary pole is nothing but given by length of the train, length of that own train, okay, own length of the train. So what is the length of the train? 100 meter. So therefore distance is also 100 meter. And speed is given how much? 36 kilometer per hour. Therefore we can find the time easily. Distance is 100 meter, but the speed is in kilometer per hour and the distance is in meter. We cannot take directly divided by 36. Why? Because the speed is in kilometer per hour, but the distance is in meter. So what we have to do? We have to convert kilometer per hour into meter per second. Then both the units will become same and then we can take the value. So how to convert kilometer per hour into meter per second? So multiply this 36 into 5 by 18. So 18 ones are 18 twos are 2 5s are, it is 10 meter per second. So now the speed also is in meter per second and the distance is in meter. So both the units are same. So now we can take distance is 100 divided by speed is 10. So 0 0 cancels, which is equal to 10 seconds. Okay, so the time which the train takes to pass a stationary pole is 10 seconds. So going on to the next problem. How many seconds will a train 110 meter long running at the rate of 72 kilometer per hour take to cross a bridge of 130 meter long? So in this case what is happening? The train which is 110 meter long, it is running at the speed of 72 kilometer per hour. It is crossing a bridge. Okay, it is crossing a bridge of 130 meter long. So the question says how many seconds it will take to cross this bridge. Okay, so we know that the distance covered by the train when it crosses a bridge is given by the length of the train plus the length of the bridge. Okay, so the length of the train is how much? 110 meter plus length of bridge is 130 meter. So totally it is 240 meters. So the distance is nothing but 240 meter. Now the speed is how much? It is 72 kilometer per hour. Now the speed is in kilometer per hour and the distance is in meter. So we cannot take it directly. So first we have to convert this kilometer per hour into meter per second. So how to convert? 72 into 5 by, just multiply anything by 5 by 18. The given number by 5 by 18, then the value we get is converted into meter per second. So 18 ones are 18 fours are. So 4 5s are, it is 20 meter per second. So both distance and speed are both in meters. So now we can directly find out time. Time is nothing but d by s. So distance is 240 and speed is 20. So it is 1s are 12s are. Therefore t is equal to 12 seconds. So the train takes 12 seconds to cross the bridge. Next problem. Two trains 121 meter and 99 meter in length respectively are running in opposite direction. One at the rate of 40 km per hour and the other at the rate of 32 km per hour. in what time will they completely cross each other from the moment they meet? So don't worry about this last sentence, when they cross each other from the moment they meet. Okay, they just mean to say that when they will cross each other. So there are two trains, one is 121 meter length and another is 99 meter length. So the first train speed is 40 km per hour and the other train speed is 32 km per hour. So they both are running in opposite direction. This is very important. So both are running in opposite direction. So when they are running in opposite direction, that is when one train is going like this, the other train is coming like this. So at how time will they cross each other? Okay, is the question. So in this, relative speed will come into picture. So relative speed of two bodies when they are running opposite is given by S1 plus S2. They both get added, speeds get added. So we know speed of first train is 40 km per hour. So it is 40 plus the other speed is 32. So it is 32. So the total speed will be 72 km per hour. So we got speed. Now what about distance? Distance is when two trains means the distance covered by is given by length of the first train plus length of the second train. So length of first train is how much? 121 meter plus length of second train is 99 meter. So totally it is 220 meter. Now again distance is in meter but speed is in kilometer per hour. So we have to convert this speed into meter per second. So how to convert? 72 into 5 by 18. So it is 18 ones are 18 fours are, which is equal to 4 fives are 20 meter per second. So the speed also is in now meter per second and distance is in meter. So therefore we can find out the time. So time is D by S. So D is 220 and S is 20. 0 0 cancels, 2 ones are 2 11s are. So it is 11 seconds. So the train takes 11 seconds to cross each other. Next problem. Two trains, one 10 meter and 90 meter in length respectively, are running in same direction, one at the rate of 50 km per hour and the other at the rate of 68 km per hour. In what time will they completely cross each other? So here again two trains are there. One is 110 meter in length, another is 90 meter in length. So they are running in same direction. This is very important. They are running in same direction. One at the rate of 50 km per hour and the other at the rate of 68 km per hour. So in what time they will completely cross each other? Okay. So we have to find out the time. So first is relative speed we have to find out. Why? Because two trains and they are running in same direction. So when two bodies are running in same directions, the speed gets subtracted. So S1 minus S2. So first speed is 68 and the other speed is 50. We just want the difference between the speeds. Don't worry about the sign. Why it is not 50 minus 68? Don't worry about that. We just want what is the difference between the two speeds. Okay. So this is 18 km per hour. Okay. Next, what is the distance? Distance is given by again length of the first train plus length of the second train. Length of the first train is 110 meter. Length of the second train is 90 meter. So totally it is 200 meter. So distance is in meter. So we have to convert speed also in meter per second. So don't write it here only. If you want to save time, what you can do is T is equal to, we know it is distance upon time. So distance is 200 divided by time, speed is 18. So that we have to convert it into meter per second. So into 5 by 18 we have to do. So directly 5 by 18 I'll write here. So instead of writing 5 by 18 like this, directly you can skip one step and what you can write 200 divided by 18 into 5 and this reciprocates and goes on top. So it becomes 18 here. So instead of writing here and wasting some time, directly in the step only you can write. So 18 cancels, 5 ones are 5, 40s are. So the time is how much? 40 seconds. So the time the two trains take to cross each other is 40 seconds. Now coming to the next problem. A train 110 meter long travels at 60 km per hour. In what time will it pass a man who is walking at 6 km per hour? So against it and in the same direction they are saying. So once we have to solve it taking against it, and another time taking in same direction. So a train is crossing a man, okay, and the man is also walking at a speed of 6 km per hour, and the train is running at 60 km per hour, and the train's length is 100 meter. Okay, first let us find out distance. Distance when the train passes a man is nothing but the length of its own the length of that train, isn't it? Own length of the train. So the length of the train is nothing but the distance. So length of the train is how much? It is 110 meter. So the distance is 110 meters. Now speed, when now first case we have to solve when they are moving against it, isn't it? Against it means opposite direction. Against means opposite direction. So when the two bodies are moving in opposite direction, the relative speed will get added, isn't it? So S1 plus S2. S1 is 60 plus 6, which is equal, means 60 is the speed of train and 6 is the speed of man. So it becomes 66 km per hour. Okay. So now what is the time? Time is equal to distance, that is 110 divided by speed is 66, but it is in kilometer per hour and this is in meter. So this also we have to convert in meter per second. So converting in meter per second means we have to multiply by 5 by 18. So 5 by 18, 18 goes on top. So write it here directly. So it is 5 ones are 5, 2s are 10, again 5 2s are 10. So 11 2s are 11, 6 are 6 ones are 6, 3s are. Therefore T is equal to 2 3s are 6 seconds. Okay, when they are moving in opposite direction, the time taken by the train to cross that man is 6 seconds. Now the second case, when both are moving in same direction. So when both are moving in same direction, what will happen? The relative speed gets subtracted, isn't it? So 60 minus 6, which is equal to 54 km per hour. Now time is nothing but D by S. D is 110, S is how much? 54, but it is in kilometer per hour and this is in meter. So we have to convert this also in meter per second. So multiply by 5 by 18. So 18 goes on top, it reciprocates. So therefore 5 ones are 5, 22s are 18 ones are 18, 3s are. So it is 22 by 3, or you can say T is equal to 3 7s are 21 and 1 will remain, 7 1 by 3 seconds. Okay, time is 7 1 by 3 seconds. Next problem. Two trains are moving in the same direction at 50 km per hour and 30 km per hour. The faster train crosses a man in the slower train in 18 seconds. Find the length of the faster train. Okay. So what happens? Two trains are moving in the same direction at 50 km per hour and 30 km per hour. The faster train crosses a man in the slower train in 18 seconds. So find the length of the faster train, they are saying. Okay. Now see here, this is one train and this is another train. What they are saying, if this is the faster train and this is the slower train, a man is sitting in the slower train. One man is sitting here in the slower train. So what happens? This faster train crosses the man in this slower train, isn't it? So whatever is the was whatever is the motion of this train, this man is also having the same motion, isn't it? Means what, with whatever speed this train is passing, is traveling, that same speed will be the man's, isn't it? Because he's sitting in that, so he'll be moving with that same speed of this train. So the man's speed is same as the train speed of this slower one. Okay, so we can say distance we don't know, because we have to find out the length of the train. Length of the faster train is nothing but distance we have to find out. So what is given? Speed is given. Speed is nothing but, speed of faster train is 50 km per hour and speed of slower train is 30 km per hour. But they are saying the faster train crosses a man in the slower train in 18 seconds. So the faster train, this faster train crosses the man sitting in this slower train in 18 seconds, isn't it? But whatever is the speed of this train, that is only the speed of this man. Okay, so that we can take directly the speed of the slower train as the speed of the man. So therefore relative speed is equal to, they are moving in same direction. Same direction means the speeds get subtracted. Therefore 50 minus 30, which is equal to 20 km per hour. So relative speed is 20 km per hour and time is 18 seconds. So distance is what? Distance is nothing but speed into time. So distance, speed is how much? 20 km per hour. But time is in seconds, so convert this also in meter per second. So multiply it with 5 by 18 into time is 18 seconds. Okay, so 18 cancels, 20 into 5 is 100 meter. So the distance is 100 meter. Okay, or distance is nothing but it is the length of the train, because the length of the train is itself the distance. Okay, why we are not considering length of another train? Because we are not taking that the faster train is crossing the slower train. We are saying the faster, question is the faster train is crossing a man in the slower train, isn't it? So when the train crosses a man, what is the distance covered? Distance is nothing but the length of the train. So therefore the length of the train is equal to 100 meters. So length of that faster train. Okay, faster train is 100 meter.